Hi students, today we will discuss some problems based on aspects of dimension. We straight away enter into discussion of the problems. The first one, 120 joule per minute convert to a new set of unit where unit of mass is 100 gram, unit of length 10 centimeter and unit of time 1 second. Okay. See, we start from here. See here, there's a problem. Joule involves time in second. But as the separate term given of time is in minute. Okay. We will first convert that unit like this. Joule per minute is equal to, we write separately, kilogram meter square second to the power of minus 2 per minute. Now we will convert this per minute to per second. Kilogram meter square second to the power minus 2. 1 minute is 60 seconds. So 60 second whole to the power minus 1. So what happened? That 1 by 60 kilogram meter square second to the power minus 3. So we have converted this joule per minute, not 120 joule per minute, but joule per minute to 1 by 60 kilogram meter square second to the power minus 3. Now, equation of dimensional homogeneity, n1, m1 to the power a, l1 to the power b, t1 to the power of c, n2, m2 to the power a, l2 to the power b, t2 to the power of c. Therefore, n2, we want to get the value of n2 is equal to n1 m1 by m2 to the power a, l1 by l2 to the power b, t1 by t2 to the power of c. Now, what is n1? 120. Along with that, this 1 by 60 also become a part of that. Okay, so 120 by 60. Then, what is m1, l1, t1? Kilogram meter second. What are m2, l2, t2 as per the question? 100 gram, 10 centimeter, again 1 second. Okay. Now to cancel, we convert these numerators to the same unit of denominator. 1000 gram by 100 gram whole to the power 1. 100 centimeter by 10 centimeter whole to the power 2. Second cancel, power minus 3, it remains unity. I haven't written that. So 120 by 60 is 2. So 2 into 10 into 10 squared. So 2 into 10 into 10 square gives you 2000. So in the new set of unit, that is where length is 10 centimeter, mass is 100 gram and time is 1 second, the new value will be 2000. Hope you understood that. Okay. The next problem, a very simple problem. Prove dimensionally kinetic energy is equal to potential energy. Okay. We know kinetic energy is half mv square and potential energy mass into acceleration due to gravity into height mgh. Now we convert them to the corresponding units. Half mass kilogram, speed meter per second. So squared meter square second to the power of minus 2. Here m stands for mass, again kilogram. G acceleration due to gravity meter per second squared and height meter. This is kilogram meter square per second square. This after simplification kilogram meter square second to the power of minus 2. So unit wise both are the same and dimensionally what are both? Kilogram m to the power 1, meter square l to the power 2, time to the power minus 2, so time. So dimensionally both are identical. Very easy one. Okay, we proceed to the next problem. The third problem. Given, see, I have curtailed the question to minimum words so that we can easily go through the problem. Given y is equal to a cos 80 to the power 3 plus x by t. Also given in the question, a is acceleration of the body and t is time. Find the dimensional formula of x. That's it. Okay. Here we don't have to worry about the total equation. Focus here. Within cos, the angle is unitless. We start from there. Okay. Angle 80 cube plus x by t is unitless. So further, since these two terms are being added, their units must be the same. Again, unit of 80 cube is equal to unit of x by t. Therefore, unit of x cross multiply. Unit of 80 cube into t. Okay. So, A, acceleration due to gravity, meter per second squared, and t for second to the power 4. Second power of minus 2 cancels with the second to the power 4, giving you second square. So, dimensionally, m square is m mass to the power 0, length to the power 1, time to the power 2. So, our answer is m to the power 0, l to the power 1, t square. Hope you understood that. Okay. Next problem. V is equal to pi p r to the power 4 8 eta into L from viscosity, where V is the volume of a liquid flowing per unit time through a capillary tube. P, the pressure head, the pressure difference between the two ends of the tube. R, radius of the capillary tube. E, eta, the coefficient of viscosity. And L, the length of that capillary tube. All these are mentioned. Say statements. Find the dimensional formula for coefficient of viscosity. Simple, straightforward. Just be careful while you substitute and simplify, that's all. See, we first cross multiply to get eta pi p r to the power 4. 8. We shouldn't forget volume per time. V is the volume of the liquid flowing per unit time. If you forget, if you don't ignore, if you don't care about that per time, we go wrong. So V by T L. Now we split. P, pressure, force per area, radius itself, and denominator, volume, length cube, and this per time comes to numerator as time, and another length. Okay. Look here. Length to the denominator also is having length to the power 4, length cube into length. Radius to the power 4. Both are length. Radius as well as length, both are in effect length. So this term cancels with this denominator term. So what remains? Force remains, area remains, this time remains. This with this cancels. So what remains? Force, mass into acceleration, kilogram meter second to the power minus 2. That area also remains m squared. Then this I have, even though it cancels here, I have shown here meter to the power 4, meter to the power 4 into 1 second time. Okay. M4 and M4 cancels. So m square in the denominator comes to numerator as m to the power of minus 2, which cancels with the 1 m term in the numerator. So ultimately we get kilogram meter to the power of minus 1, second to the power of minus 1. And what is then eta, the coefficient of viscosity dimensionally? Kilogram meter. Meter to the power of minus 1, L to the power of minus 1. Second to the power of minus 1, time to the power of minus 1. So dimensionally eta is m, L to the power of minus 1, time to the power of minus 1. That's our answer. Okay. The same question can be asked in objective model also by providing 3 other options also. Okay. Our next problem. Assume escape velocity of a launched satellite depends upon gravitational constant g, radius r of the satellite, and also the density rho. Derive the formula for escape velocity. CBSE 1997. Okay. Escape velocity VE is a dimensionless constant K into, we don't know the powers, gravitational constant to the power A, radius of the satellite to the power B, and the density of the satellite material to the power C, average density to the power C. Okay. Now equate the units. Escape velocity meter per second. K. Gravitational constant, force into distance squared by mass squared. Okay. M1, M2 to the power A. Radius to the power B. Density, mass by length cube, mass by volume to the power C. Okay. Now we further split. Dimensional constant K. Force, mass into acceleration. Kilogram, meter to the power, meter into second order of minus 2, mass into acceleration, into radius square, meter square, m1, m2, kilogram square, radius meter to the power b, mass kilogram, length cube, meter cube, whole to the power c. So now we look here, meter to the power, meter second order of minus 1, k into, we have to take a inside, and after modification, kilogram by kilogram square is kilogram to the power minus 1 in the numerator, along with this a, kilogram to the power minus a, meter into meter square is meter cube, along with this a, m3a, times second to the power minus 2a. Okay, the first term. Now the second term directly meter to the power of b, and the third term kilogram to the power c, meter to the power of minus 3c. Okay. Now, from here we go here. Dimensionally, convert them to dimension formula. Meter to the m to the power 0, L, time to the power minus 1. This term. Dimensionally, this term. Kilogram, look here, kilogram, power minus a here, c here. No other kilogram term. So, m to the power c minus a, m to the power c minus a. Now collect the L terms. Here meter 3a, b minus 3c, 3a plus b minus 3c. Length power 3a plus b minus 3c. Now time terms, second to the power minus 2a. Now the second term, so time to the power minus 2a. Now we have to equate the powers of the dimensions. 0 is equal to c minus a is equal to 0. 3a plus b minus 3c is equal to 1, because L to the power 1. So 1. Time to the power minus 2a. Here time to the power of minus 1. Minus 2a is equal to minus 1. We have 3 new equations. From first we get the a from the third equation. From 3, a is equal to 1 by 2. Minus minus cancel, a is equal to 1 by 2. Feeding this in equation 1, c is also half. Half minus half is equal to 0. Now feed back both a and c in this equation. Feeding back both a and c values in 2. 3a minus 3c cancels 0. So b is equal to 1. B is equal to 1. So we got all the powers a, b and c. So escape velocity is equal to k, dimensional constant, gravitational constant to the power 1 by 2, radius to the power 1, density to the power 1 by 2, or k r under root rho g. That is the equation we reached at. Hope you understood that. Okay. The next problem. See, number of particles crossing unit area in a plane perpendicular to x-axis in unit time. A bit tricky. Number of particles crossing unit area in a plane perpendicular to x-axis in unit time is given by minus b n1 minus n2 divided by x1 minus x2. Here, n1 and n2, number of particles per unit volume, number of particles per unit volume, Then x1 and x2 corresponding values of x on the axis. What is the dimensional formula of the diffusion constant d? A bit tricky as a whole. See what really happening here. This is x-axis. There are two planes perpendicular to the right direction of diffusion of molecules, and x1 is the first distance and x2 is the second distance, and they have given n1 by v cube, n1 by v, volume, not v cube, v is the number of molecules crossing this cross-sectional area per unit time, and n2 by v is the number of molecules crossing this cross-sectional area per unit time. These are the information given. Okay, now we substitute. See, this thing given as a statement is converted to number of particles n divided by area, unit area per time divided by time is equal to minus d. This negative sign has no role in our derivation, minus d. This to make the answer positive, they have used the negative sign here. See, number of n1 by v. This n1 can be written as a particular number per a unit volume. Okay, n1 by v, and n2 is replaced by another number n2 by v. And x1 and x2 are two distances, L1 minus L2. Then we convert the whole thing into units. N being a number is unitless, area meter square, time second, d is d. We have to find the unit and dimension of d later. N being number 1 by m cube minus another 1 by m cube. They never cancel. It is unit wise. Okay, and denominator m minus n. Okay, if you want, we can write m1 cube, m2 cube, no matter. Okay, now we can write the numerator as m to the power minus 3 minus m to the power minus 3, and denominator a m term, or d into m to the power minus 3 by m, or d into m to the power minus 4. So left hand side is m to the power minus 2 time to the second to the power of minus 2. Right hand side is d m to the power minus 4. Therefore unit of d, take that to the other side, m to the power minus 2, second to the power of minus 1, m to the power minus 4 is equal to m square second to the power of minus 1. So dimension formula. Mass is not involved. So m to the power 0, length squared, time to the power minus 1. So our answer is m to the power 0, L square, time to the power of minus 1. That's our answer. Hope you understood that. Okay. Next problem. A hypothetical experiment is conducted to determine the formula y is equal to cos theta into t to the power x tau divided by L cube, where y is Young's modulus, t time period, Greek letter tau, torque, and L length. Find the dimensional formula for x. APMT mains 2005. This is the given equation. We simply rearrange to isolate the x involving term. T to the power x is equal to y L cube cos theta into tau. Therefore, unit of t to the power x, Young's modulus unit Newton per meter square, L cube length cube meter cube, and cos theta unitless, and torque Newton meter. So if we verify this, it is 1 unitless. So x is t to the power of x is 1, so x is 0, so no dimension. Okay. The next problem. If v velocity of soil, E elasticity of the medium, and D the density of the medium, then the proper relation E is equal to V is equal to E by D, V is equal to under root E divided by D, C V is equal to under root E by D, D V is equal to under root E, E divided by under root D. Okay. Let's begin. Let V is equal to a constant. As per the options, K is 1, e to the power A, d to the power B. Now we equate the units, velocity meter per second. Unit of elasticity, kilogram, meter to the power of -1, second to the power of -2, to the power A. Density, kilogram per meter cube to the power B. Meter to the power of second to the power of meter second to the power -1. Kilograms power isolated, A plus B, A plus B. Meter to the powers isolated, minus A plus minus 3B. Minus A from here, minus 3B from here. Time, second to the power minus 2A. Dimensionally, now what? There is no mass term, m to the power 0, length to the power 1, time to the power -1. Here, mass to the power m to the power A plus B, length to the power minus A, minus 3B, time to the power -2A. Now, equate the powers of dimension, identical dimensions. Equating the dimensions. 0 with respect to mass, 0 is equal to A plus B. Dimension of length when equated, 1 is equal to minus A, minus 3B. Equating the dimensions of time, minus 1 is equal to minus 2A. From third one, we get A is equal to 1 by 2. From the first one, B is equal to minus 1 by 2. When we substitute, A is equal to 1 by 2, B is minus 1 by 2. Okay. So we got both A and B. Now feedback. We don't want this relation. Okay. Now we feedback. Look here. B is equal to K into e to the power 1 by 2 density to the power minus 1 by 2, or B is equal to K, which is 1 under root E by B. So this is the correct, C is the correct equation. Okay, understood that. The next question. Find from dimensional analysis the correct equation for the capillary rise of a liquid. Here H is elevation of the liquid level, T surface tension, theta angle of contact of the liquid with the tube, D density of the liquid, G acceleration due to gravity, R radius of the tube. Okay, and 4 different equations are given. See, listen. Here, if you write the dimension, if we approach the dimensional way, we have height is equal to a unitless constant into surface tension to the power A, density to the power B, radius to the power C, acceleration due to gravity is to the power D. Fifth one is theta, but we know theta is a dimensionless form, whether it is cosine, etc. So we don't consider. But even then, there are 4 variables. MLT methods can give you 3 unknowns, not the 4th one. So there is a chance that if you proceed the dimensional way, you may not be able to solve. So I have done the trial and error method here. Here I have approached the trial and error method. Look, in each case, I immediately convert them to their units. Didn't go for dimension, units, height. In all cases, left hand side is meter. On the right hand side, density, kilogram per meter cube, cos theta no unit, TGR, surface tension T, Newton per meter, and acceleration due to gravity, meter per second square, and radius, meter. Further, you convert Newton to kilogram, meter, second to the power of -2, and this meter to the power of -1. And you simplify that. So that, see here we have only kilogram, meter and second. Simplify, you will find that it is not equal to m. Only when it is equal to m, the equation is dimensionally valid or unit-wise valid. You do the similar operation for all the remaining 3. I am not going to explain how they cancel. It will be useless for you because you have to work out them. Okay. Only in the third case, this equation, height is equal to 2 into T cos theta, by dgr, you get meter remaining uncancelled on the right hand side. So meter equal to meter. So C is the right equation here. Okay.